Hi everyone. In this project, I worked on understanding the difference between using Django signals and using a service layer for business logic. Like the application contains two main models. One is order and user stats. Order stores the information about a user's order, such as the order amount and the status, and the user stats stores the aggregated information like amount, total amount spent by the user, and the total number of orders. In the first phase, I have implemented a Django post save signal. Whenever a new order was created, the signal automatically updates the corresponding user stats record. Although this worked for normal order creation, signals have some important limitations. Operations such as bulk create and QuerySet.update and bypass signals because they directly interact with the database and do not call the model save method. To demonstrate this issue I have created test cases that shows how user stats can become inconsistent when bulk operations are used. And after identifying this problem, I refactored the application to use a service layer. The service layer it contains a create order function that explicitly handles both order creation and status updates within a database transaction. This approach makes the application easier to understand, easier to test, and more reliable because the business logic is no longer hidden behind signals. The project is fully containerized using the Docker and Docker Compose with PostgreSQL as the database. The database migration runs automatically when the application gets starts. So now I'm gonna show you the project structure and all. As you can see, there are orders and the signal project, right? In that we're gonna get into the model. Like in the model, I have created two databases models. One is order and the user stats. As you can see, the order model stores the information about an order placed by a user. It contains a reference to the user, the order amount, and the order stats. And the user stats model stores summary information for each user, such as the total amount spent and the total number of orders. Instead of calculating these values every time, we store them separately for faster access. This relationship between user and user stats is one to one, meaning each user has only one statistic record. As we can get to see user has one to one field. It was relate it was interrelated, as you can see. And the total, they stores the total amount, and the stats, they stores the current order status, and by default it is set to the pending. And the user model one to one, this ensure each user has only one stats, and the total spent and order count. This fields keeps the track of how much the user has spent and how many orders they have placed. And while coming to the service.py, after identifying the limitations of signal, I have moved the business logic into the service layer. The service layer contains a function called create order. Instead of creating orders directly, this function handles the complete process of creating an order and updating the user statistics. Like we can get to know the transaction atomic, right? With a, I use transaction atomic to ensure that both operations happen together. If any step fails, the entire transaction is rolled back, keeping the data consistent. And the order, first a new order is created, then next this system checks whether a statistics record already existed for the user. If it doesn't existed, it creates one automatically. And the status order count and the total spent After the ordered user order count and the total spending are updated based on the new order, and everything was saved. The updated statistics are saved to the database. The main advantage of this approach is that the business logic is explicit and easy to understand. Whenever someone calls create order, it is created that both the order creation and the statistics updates while happening together. This makes the application easier to maintain, test, and scale. So let's just let me show you the demonstration. Like first, I will gonna start the application. We can simply start the application with the help of Docker Compose up hyphen hyphen build, as the entire application was containerized. It's going to take him little time as each and every line in the Docker file gets executed. As you can see, the container is started and healthy. Let's just quickly check whether the both the containers are healthy or not. So now, first time we'll run the test suits. As we can see, all the five test cases are passed successfully. The Signal related test case verifies the signal updates uses stats correctly when an order is created and also demonstrate the bulk operation bypass signal. The service layer test verifies that create order correctly creates order and updates the stats or not. There is also a test providing the direct order object dot create no longer updates user stats after the signal has been removed. So now let's me just quickly run the benchmark command. As the benchmark compares two approaches, the first approach, it's my bad. Maybe I did a typo error. Let me just quickly check. Okay. Was it? Oh, it's just nothing like I have kept benchmark instead of K. I have kept L. That's the issue. So while coming to the benchmark, it compares two approaches. The first approach stimulates the signal based limitation where each order creates casual additional databases of operations, and the second approach was use bulk create and signal optimize updates for user stats. From the results, we can see that the optimized service layer approach is significantly faster. The signal based approach and my execution, the signal approach took about 18.66 seconds, right? While the optimized service approach took only 0.2 seconds, resulting in more than like 14 times 400 and like 215 times, right? Performance improvement. This demonstrate why service layer are generally preferred for core business logics in production application, right? To conclude, this project helped demonstrate both the benefits and limitations of Django signals. While signals can be useful for loosely coupled tasks, they are not ideal for critical business logic because they can be bypassed by bulk operations and make application behaves less explicit. By moving the logic into the service layer, the code becomes more maintainable, testable, and performant. Thank you for watching.